Okay, here we go. So, I want you guys to think about these as if they have histograms behind them. Can you kind of imagine like bars, histograms behind these? And it's like somebody glazed their eyes over from like 10 feet away and sort of like traced it. So in the next chapter, chapter 3, we work with lines and we're going to do a lot of line of best fit. We call these density curves a curve of best fit. So first of all, density curves are for quantitative variables only. I want you to think curves of best fit over top of a histogram. So in chapter 1, we made the real histograms out of the real data. And these guys here are mathematical models. There is not necessarily a data set behind them. They're sort of treated like they're perfect. There are two facts that you need to know about density curves. If you're in pre-calc or calculus, there's one of them that might freak you out, but I promise you, it is not going to lead to pre-calc or calculus. These are always above the x-axis. So they're always positive area. And the area under the curve always equals 1. And I know I say area under the curve, and you look at me like you have some kind of trauma there, but we're just adding to 1. Okay. Now down here, like 3 boxes down from my density curve, I'm going to state the shape. This one is left skew. Does that make sense to everybody? Okay. This one I'm going to call bimodal and symmetric. Bimodal and symmetric. Do you guys know what those words mean? Bimodal and symmetric. Okay, and then I have a right skew example over here. Is everybody okay so far? Okay, so now if you're like me and particular, I would like to use that word, particular about your notes, you're going to want a straight edge for the next bit. I'm not going to say completely, totally weird perfectionist lady. I'm going to say particular. Okay, so what we're going to do for these is we're going to locate where the mean, median, and mode would be when talking about a left skew, a right skew, and bimodal and symmetric. So on the left skew graph, I want you to find the highest point for you, whatever your highest point was, and draw a line. And that will be the mode. Remember from middle school, mode is the most, that occurs the most, so that is the highest point in your curve. Okay, now we're going to do some chapter 1 review. The median is resistant to skew and outliers. So it will be closer to the mode. I don't care where you put it. We don't really know where it is. So we're just winging it. But we know the median is resistant to outliers. Does anybody know why it's resistant to skew and outliers, mathematically speaking, like calculation speaking? The way you calculate it? Yeah, you're ignoring all the numbers except for the middle. So that's why it's resistant. And then the mean will be somewhere in the tail. Again, I'm not making these to any particular scale. I don't know where they would be. I'm just saying the mean is not resistant to skew and outliers because when you calculate the mean, you use every single value, correct? So the mean, I'm going to say all year will be pulled into the tail. Does it make sense to you that the right skew one will be the exact opposite, like symmetry? So let's do that one. And for the last guy here, he's going to have two modes. So go ahead and draw in your two highest points. I don't care if you guys made them equal. I don't care if you made one bump higher than the other. I'm just going to call them mode 1 and mode 2. Mode 1 and mode 2 might be equal depending on the situation. Okay, and because it's roughly symmetric, just find wherever the middle-ish of yours is. I'm gonna go there. Again, we're estimating off of like sketches, so it's okay. And because it's roughly symmetric, the mean and median should be about the same. So we're going to put mean and median. Anyone have any questions so far? Anything I can clarify for you? Does it all make sense at the moment? Pretty good? Okay. All right, now I have more for you to write. So you should chat with each other while you do this. You can chat, really, it's fine. Or not. I could tell you about my evening. So I went home and then um I fed my animals because I don't know about you, but like the first person to get home has to feed the animals because they're just like freaking out about getting fed. So I fed the animals and then I put on my uniform. My uniform is some kind of ratty t-shirt and pajama pants. Basically what I live in when I'm not here. And I laid on the couch and I played on my phone for a really long time and ate almost an entire bag of barbecue chips. And I was watching Let's Marry Harry and playing some game called Tasty Travels where you like merge different foods and then put like orders and it's a good game. It's like Gossip Harbor. It's just like that one. But I got tired of that one. So now I'm doing Tasty Travels, which is exactly the same thing. But whatever. Okay, then my husband called and he was driving home. He didn't get home till like 7:30. And I felt really guilty because he was like had a super late night and I had just laid on the couch for an hour doing nothing. So I got up and I watered the plant and got about 6 new bug bites. And then he reminded me we have off in the garage. I don't know why. I didn't, you know, think to put the off on, so I didn't. So I have 6 new bug bites, which is great. But the plants were set. And then I did that thing where like, I don't know. So I'm the only girl that lives in our house. I don't know if this is a girl thing, but like all of the boys in my house, and I don't mean to be like gender biased here, it's just an observation of the Talbot house, starting with their dad. So I don't even know. They don't like put more of something where when they take the last one. So there was no paper towels, no Kleenex in the front bathroom, and no paper plate. So I restocked all that stuff. And then, um, I started to make dinner while he was on the phone, and we had nachos that were made out of ground beef and salsa and deliciousness. And then I watched my two favorite YouTubers while we were eating nachos on the couch. What? It sounds like a pretty good night. Yeah. And then he did the dishes and I forced myself to grade my math one quizzes from yesterday. I finished them. I did it. Look at the responsibility of it. And then my stepson came home from Trader Joe's. He works at Trader Joe's and he gets off at 10. And we had to hear about how his first day at Napa Valley College was. And apparently he did not read the description of the class that he signed up for very well. He thought it was going to be like a drawing and painting style art class, but it's like a art history class. And it's 8 in the morning. And he was there like trying not to fall asleep with this monotone guy is like giving him notes on different paintings. Yeah, that was a mistake. Anyway, and then we went to bed. How does Mrs. Talbot's night sound? I did good. Are you guys set up here in the notebook? Yes. Um, okay. Most of the YouTubers that we watch at my house are car related because my family's a car family. So my favorite YouTuber is Cletus McFarlane. You should watch him. He crashes everything. It's great. He's all so happy. This man has never had a bad day. He's just happy all the time with his millions of dollars and many cars and crashing and racing and things. And then the other one, you're going to hear a lot about this one this year, whether you like it or not, is Vegas Matt. I watch Vegas Matt every single day because I'm a statistics teacher and I watch the gambling every single day. So our chapter 5, the spicy chapter that we have, I'm going to put it all themed around gambling because that's what I know best. So anyway, so yes, even though I know that it's like impossible to win over the long term, I still watch it every day. Okay, anyway, let's do this, which is not nearly as fun as slot machines. Uniform density curves. I have to tell you something very honest right now. I have never seen a uniform density curve on the AP exam. So I'm only going to do one problem just in case. It's a rectangle, so it's not that big of a deal, but I'm not sure if it'll show up or not. I just want to make sure we're covered. I'm just going to do one problem and then we're going to walk away from that. So uniform density curves are a special density curve where every outcome is equally likely. And you can think about a uniform shape. I always call that like a buzz cut. You guys know what I mean by that? Like a boy's buzz cut. Like it's not perfectly flat, but it's like, no, okay. Assume that the probability of having an earthquake in Venetia is equally likely over a period of 40 years. Draw the uniform density function to represent the situation. Okay, because it says uniform and because we're dealing with mathematical models today, which means perfection, it's going to be a perfect rectangle. So I am going to go over 8 boxes. I'm going to go like this. I'm going to go 10 years, 20 years, 30 years, 40 years. And then I'm going to make my rectangle here, and I'm going to make it 4 boxes tall. You can make it as tall as you want. We're not actually done with A, but I'm going to do the last bit over here. When you draw a uniform density function, you can decide how to scale your y-axis. You can just honestly make 1 dash at 40 for this problem. But I knew what B was coming up, so I made it go by 10. But anyway, they're always rectangles. You only really need one label, but we do need to calculate the height. So there's one formula that we use for these problems, all of them. If you ever see a uniform density function problem, they all use the same formula, and it's nothing you've ever seen before. It's area equals base times height. I know. Shocking information here. Okay, now the piece of information you need to grab is the second bullet point from above. It says the area under the curve always equals 1. So the area is always going to be 1. The base in this particular problem is 40. Okay, and that is a completed uniform density function. So I labeled my base, I labeled my height, and I put in my title. Area is always going to be 1, and you'll always be able to figure out the base and solve for the height. Okay, B. About what percent chance is there of having an earthquake between year 16 and year 32? So I'm going to go to year 16. And year 32. So this is the area that we're interested in right here between year 16 and year 32. And as I said, there's only one formula that we use for all of these uniform density problems, which is probably why they're not on the AP exam, because it's just not that fascinating. What we want to do is find the area of this shaded region. So area equals, for the base, I'm going to say 32 minus 16. Does that make sense to everybody? That the base would be 32 minus 16 long? Okay, and then the height is 0.025, which is 0.4, so 40% chance. So apparently that rectangle is 40% of the big rectangle. That might be the only one of those you ever do, but I felt the need. I talked to Chad about it, and he was like, "You can't completely eliminate it, but you just do one, so at least they have an idea of what it looks like." I ran it by my colleague, lively colleague. Anyway, okay, so that's it for 2.2a. Now we're gonna do 2.2b, which is much more interesting and is the normal curve part. Is there more drawing? Yeah. Hopefully you have that bottling plant soda bottles example from yesterday. That gets pasted in right here. Like, what did I do with that? You guys remember doing a little bit of histogram and box plot in math 3? You actually learned one variable stats in math 3 also, you probably don't remember. Miss Rice and Miss Franco have decided that I need to be the one to write the histogram box plot test question. I wonder why. Okay. All right, so let's fill in these bullet points. The normal density curve, super important. This is the distribution that basically overlaps almost all your other curriculums. If you're talking about distributions in psych, it's going to be normal most of the time. There is also the name normal distribution. And then if we're really lazy, we just call it the normal curve. Try to capitalize your normal because that means something specific. It's not, doesn't mean that it's like just the usual, the opposite of Mrs. Talbot, you know, that kind of normal. It just means that like, it actually follows a specific mathematical pattern. It doesn't mean that all other distributions are abnormal either. It's just its name. Okay, so things you need to know. It is symmetric and bell-shaped. And because it's symmetric, that means the mean and median are equal. Like completely equal, like perfectly equal every time. Because remember, we're not talking about data sets here. We're talking about perfect mathematical models. So you're hazing your eyes over and curve a best bet. Okay. It's defined by its mean, mu, and standard deviation, sigma. And the curve goes out about 3 standard deviations on each side. Okay, really, really big, important, but challenging question. Why did I use mu and sigma there instead of x bar and s of s? Yes. Yeah, these are perfect mathematical models, which means that that is the perfect mean and the perfect standard deviation. Those are not from a sample, but that is from a theoretical mathematical model. So that's why you're using those fancy stuff. Good luck with drawing your standard deviation. It takes a while to draw that properly. It's like a backwards O with like a little tail. I don't know. Okay, the empirical rule, 68% of all of the data values in a normal distribution falls in one, that doesn't say one, falls in one standard deviation on either side. Okay, so I'm going to come back here as we do this, and I'm going to label my normal curve. I leave this up all year, so congratulations. So this interval here is indicating 68.3. We say 68. All of the other disciplines use the whole numbers. They just say 68. So like inside, they're going to say 68. We're statisticians, so it's 68.3. But for now, we're just learning the basics. So I'm just going to say 34, 34. Did you like the jazz hands? Yeah. Okay. Now, you guys can tell I'm going to round 95% falls in 2 standard deviations on either side. Okay, somebody have their calculator out. They could do 1 minus 0.68 hold on. 0.95 minus 0.68 divided by 2. Yeah, hit enter and then divide by 2. Yes, okay. So each one of these sections, this whole thing adds up to 95. So this is 13.5. And this one is 13.5. Does it make sense? Why did I put degree? Does it make sense that all 4 of those add up to 95? Even though it's like, we're statisticians. They're just really meager using of our curve. Okay, and then for some reason we do use the 99.7 in the third one, and I think it's because you can't really say 100%. That's why I said about 3 standard deviations on either side, because it's not really perfect. It technically goes on forever in both directions. And you always might get some kind of really wonky value that's just way out there. You just never know. Okay, so I'm just going to fill it in the rest of the way. So those are 13.5. These guys are 2.35% each. And this little dude, that's this little tiny piece here, is 0.15. Okay, so now we're going to do something really fun and make our own normal curve. So if you could go in your packet and find the giant normal curve. Guessing. Sure, sure. Did you find him? Okay. So we are going to write the percentages in each space. And you could get them from the back wall if you need them. So 34, 34, 13.5, 13.5, 2.35, and then this little piece, which is just like not really showing up, but it's definitely there. Okay, we're gonna add 2 things to this, 3 things to this page. The first thing that I want to add is the z-scores. And the middle is 0. And remember, the definition of z-score is the number of standard deviations on either side. So this is 1 in the positive direction, 2 in the positive direction, 3 in the positive direction, 1 in the negative direction, 2 in the negative direction, 3 in the negative direction. Okay, and the last thing I want to do is I want to tie this into Monday's lesson that we already did and talk about the percentiles. This is going to require you to draw a long line. So you might want to go grab a full-size ruler for your group. I don't know where mine is. You can do it with the You can do it plenty with the protractor, but as I said, I'm a particular kind of lady, so. You guys all see where I put my tick mark? Does that make sense? Okay, so I really want to make sure everyone is going to memorize percentile means less than or equal to. We're gonna use it all year. So when I say the word percentile, I want your brain to go less than or equal to, less than or equal to. Okay, and it's cumulative less than or equal to. So in this spot right here, it would be at the 0.15th percentile, which is not something you would normally report because percentiles are usually whole numbers, but it's okay because we're doing an exercise here you'll see. Okay, so then if I add those two together, from here down is the 2.5th percentile. So everything less than or equal to. This is the 16th percentile. Everything here and down. This is not shockingly the 50th percentile. Okay, 50 plus 34 is 84, so this is the 84th percentile. Plus 13.5 is the 97.5th percentile. Plus 2.35 is the 99.85th percentile. Does that make sense how I calculated those? Okay, last thing for your big normal curve. I would like you to color it 3 different colors. One color for the 34s, one color for the 13.5s, and one color for the 2.35s. And I'm going to show you this like it's a baking show. You know how like they bake something and then they put it in the oven and they're like, oh, 1 second later they get it out and it's done. Oh, 20 minutes has passed. And look, that's definitely not my paper from last year. No, no. It doesn't have to be these colors, but any 3 colors you want. Anyone, this is gonna sound really weird, but has anyone seen the movie Spaceballs? What? You have seen the movie Spaceballs? Well, I have been known to refer to the normal curve as dark helmets. Just, and you know, you can't unsee it. I'm so sorry. But no one gets it because no one watches baseball anymore. Become black. But thank you so much if you see dark helmet in my normal curve. Really appreciate it. Matthias, you are now required to draw me a dark helmet on your chapter 2 test. Thanks. Your illustrations, they're wonderful. I love them. They make me so happy, except for they completely ruin like the unbiased grading part because I could tell it's your paper every time. Mr. Talbot was like adding up the points, and I was like, you don't have to look that one up. That's Matthias. Mr. Talbot is the best TA of all time and most adorable. Okay, once you're done with this part's done. Just scooch it off to the side. Don't close your paper. You're going to want it again. Just scooch it over and go back to your notebook. And we're almost done already. We just have to actually do a couple math problems with this, like what on earth did we draw this whole thing for? And then we're done. And there were several people who told me they had homework questions, so I want to make sure I talk to those people when I'm done with this. There were several. Oh, and I can't forget my joke. My joke today is good. I already looked. You're gonna wonder why I do not have it as a t-shirt. How I don't have it, I don't know. I couldn't have worn it today anyway because, you know, normal curve doesn't go away all year though. I do too. Sorry. Okay, so when you get back to your notebook, you're going to draw your own dark helmet. This is the only time I'm going to ask you to try to draw the dark helmet like proportionally speaking. Most of the time I just sketch it, or I give you this, which is what I'm gonna give you on Friday, which has a bunch of them on there, so you don't have to draw it. But anyway, um, what I did was I made this. I started at the center, and then I went two, 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 where the x-axis starts, and then I went up 5 dots to the top, and then I went up 3 dots, and then 1 dot, and then I just sort of went. These, for my pre-calc and calculus students are supposed to be inflection points. So this is supposed to turn it concave up from concave down. You think I don't know my stuff? I do. Do that, Morris. Too much. You guys have so much PTSD. Much art today. Just thought of. And there's only an A and a B, and then we're done. It's not bad, I promise. Okay. The first thing I want to do is read the problem. So if you're still writing, that's fine. Go ahead and finish up your paper. Sketch the normal curve representing this scenario. A bottling plant fills soda bottles, soda, with a mean amount of 502 milliliters and a standard deviation of 1.8 milliliters. I don't know if you know this about me, but I have a minor problem with zero sugar soda. I love it so, so very much. All of the zero sugar sodas. It's like my favorite thing. Anyway, okay, now this still has the same percents inside. So first thing I want you guys to do is label your same percent straight off of your big normal curve that you made. Just look at that one or mine. So when it says normal, that means that it follows this distribution every time. Those values do not change. Those are constant. However, this problem is not working with z-scores. This problem is working with an actual problem with values in it. So what I mean by that is the mean is 502. It's not 0. So this is 502. And what you're going to do is you're going to add 1.8 3 times to go up the x-axis and subtract 1.8 3 times to go down the x-axis. So 502 plus 1.8 plus 1.8 plus 1.8 502 minus 1.8 minus 1.8 minus 1.8 And because we're educated souls, we make sure to label our graph. Okay. Anyone have any questions so far? Do you guys all understand how I got the values on the axis? Do you guys all understand how I got the percent? I mean, other than the fact that I just told you what they were. The last thing I want to tell you is kind of a cheat. College Board wants you to always state what the mean and standard deviation is in the problem. But if you're lazy, like me, you can do it shorthand by putting a capital N, and it's going to look like a coordinate 502, 1.8. That is acceptable College Board notation for stating that something is normal with a mean of 502 and a standard deviation of 1.8. If you don't have to write all that stuff out, you can just say that, which is amazing because we're lazy. I mean, I'm lazy. You might not be lazy. I'm definitely lazy. Okay. What proportion of bottles are filled with less than 502 milliliters? Okay, so come up to your curve, shade in. Up to 500 and 500.2. And all I have to do is add those 3% together. So 0.15 plus 2.35 plus 13.5 equals 16%, which should sound familiar from our percentiles. Does everybody see where I got the 3 percentages from? Why I shaded in this direction from 500.2. Does that make sense? Okay. Is anyone upset with the fact that it says less than or not less than or equal to? You're like, should I be? I don't know. She's no. Remember that lines have no area. The area of a line is 0. We're talking about areas. So we're talking about this shaded region, and this teeny tiny shaded region. We're not talking about the boundaries at all. Okay. Last question of the day. I'd like you to write this one down and figure it out in your groups, please. You can definitely speak about it. That's fine. Okay, don't look at the screen until you're ready. Spoiler alerts on the screen. How did we do? Okay, this is the last thing I want to say before my joke. Yeah. Friday, I don't know if anyone's brain is going, yeah, that's cool. This is great. Super awesome. I found stuff. But what happens if I want to know something that doesn't lie exactly on the line of the standard deviation? And that's what I'm teaching you on Friday. So these ones are like perfect ones, and then we'll work with the whole curve after that. I'm going to take those lines off in the middle, and then I'm going to teach you how to find stuff anywhere in the curve. Okay, last thing is my joke. Okay, did we define and describe density curves and locate the mean, median, and mode? Yes, we solve a problem. I had to change that. Instead of solve problem. Solve a problem using uniform density curves. Define, sketch, and describe normal density curves. Solve problems using the empirical table. Look at us. Look at how much you learned today. Okay, here is my joke. How do I not have this t-shirt? I don't know. Don't you think I should own that? Yeah. And I'm sure they make one. So you guys can work on your homework for the last 20 minutes, or if you have questions for me, please come over. Yeah, just take the other passenger.